I really hate to cancel class without much notice, um, but I felt terrible. So I lost my voice over the weekend. I had a couple of days where I couldn't talk. Um, I have no idea what happened. I went to the doctor. I didn't have strep, didn't have the flu. I don't know what it was, but it's a couple of days of not feeling well. So, anyways, I apologize for that. I'm not a big fan of subs. I mean, it's hard even as a sub myself to go in. I'm not sure what the teaching style is, what the students are used to, and you wind up having to go over it anyway, usually. So I just figured I would give you the day to go and review what we had done, and that's why I gave you that assignment. So hopefully everyone was able to take a look at that. Were there any questions off the assignment that you wanted me to look at? Okay. If you have the page and the number on, oh, I gave you it was out of the review, right? Chapter review. 393. Which one, 79? No, 59. 393. 393, number 59. 61. Subtract and then all that? Okay, so I'm looking at number 61. It says subtract, and it gives you parentheses 12a cubed minus 5a squared plus a minus 15. Subtract from that 2a cubed minus 8a squared minus 4a plus 7. Right? That's the one? Okay. So what we want to do here is get rid of these parentheses. Ooh, get rid of those parentheses, right? How can you get rid of the parentheses there? Just distribute, but on the second set of parentheses, I have to change all the signs, don't I? So, and in the first parentheses, I don't have to change anything. So I'll have my 12a cubed minus 5a squared plus a minus 15. And then when I take this negative sign and distribute, changes all the signs, so it'll become minus 2a cubed plus 8a squared plus 4a minus 7. Okay. And after that, you just collect all your like terms together, right? So my like terms, I've got some a cubes here, right? So 12a cubed minus 2a cubed is how many a cubes? 10, right? You don't do anything with the a cubed, right? It stays a cubed. And then my a squareds, I have negative 5a squared. I've got a positive 8a squared. Add those together, I get, or put those together, plus 3a squared. Then I've got a couple of a's here. Put those together, plus 5a. And then finally, negative 15, take away 7, negative 22. Okay? Uh-huh. Any others? 85? Oh, it has fractions. Oh, that's good. Me too. When I was growing up, my grandfather, um, he never went to college. He was in the Navy for a long time. Then he was an car insurance adjuster or something. But he was very bright. He was a very bright man, and he claimed himself to be an inventor. And like cruise control in your car. He had invented that way before it came out. He just never, like, he had it all written out. He had already created the whole thing. He just never got around to, like, doing it, like patenting it. He has, like, 20 different things like that. Garage door openers, variable valve timing on engines, all these things that he used to do, right? So anyways, the point of the story is that when I was about 9 or 10 years old, I went to go visit him, and he had a shop, a metal machine shop in the back of his house. And they lived in a different state, so I only saw him a few times in my life, really. And I went, and he had me hold a big old, those video cameras that used to have the VHS tapes in them. I would sit there, and I'm like 10 years old, and he's like, he's got like an engine block, with the exhaust going out the roof, and it's like totally dangerous, and he's having me film stuff, and I'm sitting there like shaking, and in that dialogue back and forth, he was doing problems by hand, and there were a bunch of fractions, and he's like, what's 3/8 plus 1/2, and I'm like, just shaking, I'm like, because he was so quick, so smart with fractions. I never was like that. I'm still not like that. I mean, now I have to be kind of, but like fractions, there's certain people that are really, really good with fractions and enjoy fractions. Then there's the rest of us that we're just kind of deal with them, right? So I'll never forget that, though. He could do all of the fraction stuff in his head. Yeah, I mean, he scared me. He was intimidating how smart he was. Yeah, measuring. That's what he was doing, measuring, Yeah. Uh-huh. Yeah. If you work with it all the time, it's very natural. Yeah. It's a different story, right? Yeah. Okay. I'm sorry. I'm trying to stay on track. I'm not on any medication today or anything, so I don't have any excuses here. All right. So what are we going to do here? What do we have? We need to first identify what this is. We have two terms inside of parentheses and two terms inside of parentheses. And we are asked to do what? What's the operation here? Multiplication. So we're trying to multiply two what? Binomials. Good. This is a binomial times a binomial. So what we need to do is that little thing I showed you where you start with the first one, distribute through, okay? So that's what I'm going to do. I'm going to have to first multiply the 3/4 times the 8a. 3/4 a times the 8a. Let me just write down what I just said. I'm doing 3/4 a times 8a, right? That's that first multiplication. Then my next multiplication will be the 3/4 a times a positive 16. So it will turn out to be positive. It'll be 3/4 a times 16. The next multiplication, I move on to the -7 now, right? So I've done both. I've done the first term here, 3/4 a. I've distributed it to both. Now I move to the -7. I do that to both. So -7 is going to multiply times 8a. We can probably do that one without having to write it all out, right? What's that? -56a. And then the last multiplication there, is it -112? Okay. Okay, so let's get back to that first multiplication we had here. Because multiplication is commutative, meaning you can move it around, 3/4 times 8 is what we want to do, right? And 8's the same as 8 over 1. So we're doing 3/4 times 8 over 1. I'm doing it on the side here. Now you can either multiply across and say 24 over 4, which is 6. Or you could cancel out here, right? Reduce this out, and you'd still get 6. So either way, that should turn out to be 6. Agreed? Okay, 6a what? Squared. Good. And then plus, same thing here. I'm doing 3/4 times 16. So you can make that a 16 over 1 if you want. Multiply, cross, divide, or just reduce 16 divided by 4 is 4. So what should that be? 12, right? I thought I heard you say 12, right? 12a. And then the rest, I just bring it along. 56a minus 112. And we have one more step. Combine the like terms in the middle. And we'll get 6a squared minus, what is it? 44a minus 112. That's it. I agree. Okay. So I asked you to do those problems, the chapter review problems for 2 quiz grades, right, and have it ready to turn in today. The reason why I did that is because it's a good review leading up to our exam, which is, I don't know when our next Thursday or Tuesday. Yeah, I think I'm going to move it. It's on the schedule for next Tuesday, a week from today, but I think it'd be better if we do it on Thursday. Because next week is the week before spring break. So if we do it next Thursday, we take the test on Thursday, we're done, you go on spring break, you come back. If I actually try and teach you 6.1, which is really on the schedule, you'll forget it all anyway, and we'll have to come back and talk about it again. So I think I actually built that little buffer in just in case, and we're going to need it. So today what we're going to do is actually 5.6. And then on Thursday, we're going to do 7.4. And then Tuesday of next week, we'll do a review for the test. And then Thursday, next week, next Thursday, we have exam 2. That date is March 6th. For the exam, you mean? You're going to be around? Talk to me later. Yeah. All right, so that's our plan, all right? You might notice here that I didn't put 5.5 on here. Anyone notice we haven't done 5.5? It's on our schedule. The reason is because they call that, the section is called special products. And it teaches you how to multiply binomials together if they have a certain pattern to them. And you don't need it, okay? You know how to do 2 binomials right now. We just did one. So we don't need that section, and I don't want to bog us down with it because a lot of students don't really wind up using the cute little formula that they have in there. So I'm going to just skip over it. 5.6, though, we do need, all right? So let's do this. I'd like for you to turn in what you have for the review, or the problems that I asked you to do. Let's turn them in. I am going to get these back to you today at the end of class. I'm just going to look through it, look that you made an honest effort at it. I'll give you 2 quiz grades. I'll take attendance based on this. I'm going to take attendance based on if you turn this in. That means if you didn't turn it in, if you're not turning this into me today, then you need to talk to me because you'll be counted absent and you'll lose to. No, it's okay. As long as your name's on it, though.
I don't know.
So if you don't have it, make sure you talk to me before you leave today. That way I can ask you why you don't have it, and then I can count you present. You don't need the staple. As long as your name's on it, I'll keep it in order. And you don't need to do any fancy corner folding. Yeah, a little off topic, but something for other classes. I've asked most of my colleagues how they feel about, you know, those cute little folds that people do on the corners when they don't have staples. And almost unanimously, we all do not like it when students do that. We would rather have you leave it and maybe put your initials on the other pages or something like that. But to do those little cute little folds, all that creates is a difficulty in us because it gets hung up on stuff and it's just not good. So my advice, don't use those little cute folds in the corners. All righty, here we go. 5.6. So the only thing we haven't done with polynomials is division, right? Division. That's the only thing. So, you know, we first started out this chapter, we added and subtracted. Then we went to multiplication. We did, you know, monomial and binomial, monomial and trinomial, and all the different combinations. Now we're going to look at division. Division is the most complicated. It's the most challenging. And so we're never going to do like on a test, I'm never going to give you like trinomial divided by trinomial. We're going to keep it pretty basic, kind of middle of the road, okay? We'll see if I can hold up here today. I know everyone's like, come on, lose your voice. Hurry up. Come on, man. All right, so let's take a look at our first example in 5.6, dividing polynomials. I'm going to apologize about the video. If anyone watches this video, it's going to suck because it's loud when I cough. All right, here we go. 16x cubed y minus 8xy squared divided by 6xy cubed. This is our first example. Did I bring my drink? I didn't bring my drink up here. Damn it. Okay. We have division, don't we? I mean, the division, big old division bar. The numerator is the top or the bottom? Top. The numerator is a what? Binomial, two terms, right? Two terms separated by subtraction. So we have two terms. We have a binomial divided by a monomial. Okay, anytime you divide by a monomial, this is the easiest case we're ever going to see. Monomial in the bottom. Okay, this is what we do if you have a monomial in the bottom. You break the fraction up into two pieces. So you're going to take the first term here, and then you're going to take the second term, and make sure you grab that minus sign with it. And you're going to do each one of those over the bottom. Okay, so it'll look like this. You'll have your 16 x cubed y. You're going to divide it by 6 xy cubed. And then I'm going to put plus negative 8 xy squared over 6 xy cubed. Now, a couple of things to point out. Splitting this up, like I did, you can only do if you have a monomial down here. Okay, that's the only time you can ever split it like that. If you had a binomial in the bottom, you could not do this. And it just goes back to the idea of how do you add fractions together? If you have two fractions, you have to have the same denominator, don't you? Here, don't we have the same denominator? And then to add those together, wouldn't you just put the tops together? And then you just rewrite the bottom? We're just kind of undoing the addition of two fractions. We're going backwards with it. You see that? So now with each one of these, oh, I also want to point out the plus sign. Notice I put a plus here, and the negative in front of the 8, I brought it up here. You could have put a minus here, but then you couldn't have put the minus there also. So my advice to you is if you ever have a monomial on the bottom and you have multiple terms, you're going to split it up, always put plus signs between the fractions and just make sure whatever signs in front of the, the coefficient here, just make sure you put it here also. On the top. Mm-hmm. All right. Now, let me remind you, remember this property? If you have x to the n divided by x to the m, that's x to the n minus m. Remember that? Subtract the powers. Same base, different powers. You subtract the powers, right? Notice that in each one of these fractions that I have now, I have some of that happening. Do you see it in there? On those x's, I've got an x cubed over an x, right? What about the other one, though? What about the y's? I have y to what power there? The top is y to the first, isn't it? Okay. So let's just do those right above them. Let's just figure out what those are. What's x cubed over x? It's x squared, right? Because you go 3 minus 1. It's x squared. Is that all right with everyone? What about this one? What's y over y cubed? So that's y to the minus 2. Good. And that's the same as 1 over y squared. Which really just means that when we do the x's here, we have an x squared left on top, don't we? When we do the y's, we have a y squared left on the bottom. Would you all agree with that? Now we still have to take care of the 16 and the 6 here. Just reduce it. What number goes into both 16 and 6? 2 goes into both of them, right? 2 goes into 16 how many times? 8. 2 goes into 6? 3 times. So that should turn to 8 on top and 3 on bottom. Okay, let me continue my answer over here. I'm going to separate this. That's here. So this becomes equals, right? Equals. We said 8 on top. What else was on top still? X squared. And then that y to the negative 2 is going to wind up going back down, so I'm not going to put it on top right now. On the bottom, what do we have? The 3 that was from the 6, right? And then the y squared. Plus? Or minus? Well, let's see what we have. What can we do here? How about these x's? How about the x's here? They disappear, right? X divided by x is 1. So that's just a 1. And then what about y squared over y cubed? That becomes a y to the negative 1, which really means that we'll have a y where? At the bottom. And then what about the negative 8 and the 6? What number goes into both of those? Negative, we get 2 on the, 2 goes into both the top and the bottom, right? So how many times does 2 go into negative 8? Negative 4. So I have negative 4 on top. I'll put my plus sign here. Negative 4 on top. Is there anything else on top? No, right? The x is canceled. And on the bottom we had a y. And then, oh wait, yeah, 3. And then the y. So I'm doing some of this mentally because we've done this, the part in the yellow and the pink and the blue, we've done that in homework and we've done it over past sections. So I'm showing a little less of that, but if you needed to write it on the side like I did on these, then go ahead and do it. And that's it. Okay, questions? I'd like to move on to the next example. Well, yeah, do you feel like you could do that or you want to see another one of those? You want another one? Okay. Do you have a question? Where? This one right here? That comes out 2 minus 3, which is y to the negative 1, but then we drop it down, and so it appears down here. Just ask if there's anything that I'm doing that you're like, just ask. Okay, let's do another one then. What about 5x cubed plus 35x to the 9th minus 10x over negative 20 x to the fifth. So this is division of polynomials, right? Division. What do you have in the denominator? Well, yeah, denominator's a monomial, numerator was trinomial. So because we have monomial in the bottom, we're happy because it allows us to split this up. How many different fractions can we create then? 3 of them. Okay? So that's what we'll do. I take my 5x to the third over 20x to the fifth. Then I put a plus sign. Always put a plus sign. 35x to the ninth over negative 20x to the fifth. Plus sign. Negative 10x over negative 20x to the fifth. Questions on that? Let's figure out what these powers on x are going to be here. How about the first fraction? X to the third over x to the fifth is what? What's that going to turn out to be? X to the negative 2, which means we're going to drop it to the bottom, which means we're really going to have an x squared on the bottom, right? And then what about the numbers? 5 over negative 20. A 1 on top and negative 4 on the bottom, right? Okay. So we'll have a 1 on top. That was the only thing left on top. We have a negative 4 on the bottom, and we had the x you said squared, right? Plus. What about the x to the ninth over x to the fifth? That's x to the fourth. Top or bottom? Top. What about 35 over negative 20? What goes into both 35 and negative 20? 5 again, right? So 7 over, or 7, and what else is up here? X to the fourth, good, over negative 4 again, right? Plus, yes. Yeah, because 5 goes into both. 5 goes in 35 7 times. 5 goes into negative 20, negative 4 times. All right. How about the blue there? It's going to be x raised to the negative 4, right? And that's because there's a 1, right? There's a 1 on that x on top. 1 minus 5 is negative 4. So that becomes an x to the negative 4, which really drops down, becomes x to the fourth on the bottom, right? So I know I'm going to have an x to the fourth down here. What about numbers? What, to get the x to the fourth? Are we talking about the blue part anymore? Or you want to? Are you? Okay, so you're looking at these now. What number goes into both of those? 10, right? But isn't a negative divided by a negative positive anyway? Right? So that's going to turn into a plus no matter what. But 10 goes into both of those. 10 goes into 10 how many times? 1 time. So I need a 1 on top. And then on the bottom, it goes in 20 twice. That's it. I mean, it wouldn't be wrong to put negative, negative, but a negative divided by a negative is positive. So you don't need it. Yes? Yep. Do not put it back. If you put it back together, it'll wind up being what it was when you started. Yep, that's what will happen. Because to put these back together, you have to get a common denominator. And then when you get that and put them together, you're going to wind up with that. So we're done at this point. Okay, any questions on this? You'll have to practice. Now, let's move on to the next type of division. And you might want to make a note back on these 2 examples. You might want to put something on the side here that tells you this was division by a monomial. Okay, make sure you know that that's what we did when we had a monomial. We were dividing by a monomial. This is the way it was done. Same with this one. Dividing or division by a monomial. Now we're going to talk about dividing by something other than a monomial. And this is where things get ugly. So before I start, I would like for you to revisit something from way back when. Way back when. If I went and I wrote this down, I'll start it this way. If I wrote 5 divided by 3, and let's say you were like in, did I say 5? Yeah, I already was saying the answer, sorry. If I say 15 divided by 3, then back way when you first started learning, math, you would have learned this thing called division. In fact, we called it long division, where you put the 15 in here, you put the 3 out here. Do you remember that? And you'd say to yourself, okay, what do I multiply 3 by to get 15? Right? You'd say, what do I multiply 3 by to get 15? And then hopefully you were pretty good at your multiplication tables, and you'd say 3 times 5 is 15, and you put 5 here, right? And then to check it, you would go 5 times 3 is what? 15. You put it underneath. Do you remember that? You would subtract the 15, and you would get 0, wouldn't you? And you'd be done. Did you ever do something like that at some point in your life? Okay. Or how about this? How about 15 divided by 4? You would get a remainder, right? But this is the way we would do it back in the day. We would go 15, we would go 4, and then we'd say, okay, what do I multiply 4 by to get 15? You go, well, it doesn't go in there, right? It's not perfect. It doesn't fit perfectly into 15. So you say, you try and come up with something that gets you close to 15 without going over, right? So you would use what? 3, right? So I put 3 here, and then I say what? 3 times 4. So I go 3 times 4 gives me 12, and I put it underneath, right? And then I put this, subtract the 12, right? So you minus that 12, bring it down, you would have what left over here? 3. And then technically, you were supposed to now ask yourself, can 4 go into 3? And it doesn't. So that would be your remainder. Remember that? And so you would put up here, remember this, R3. Okay. Believe it or not, we're going to be doing something similar to this today. But we're not going to be using numbers. We're using polynomials. But it's the same process. Now, let's talk a little bit about this remainder. The remainder here, remainder 3, what it really means is this. This right here really meant, back in the day, 3 plus 3 over 4. So the 3 here is the remainder, okay? That 3 is that 3. The 3 here is the 3 out front. And what's the 4? It's what we call the divisor. That's your 4. So when you say 3 remainder 3, it really meant 3. Your answer is 3 plus 3/4. Okay, let's see how we're going to use this today. I'm going to start a new page. Let's say I want to take yeah. 7x squared minus 59x minus 36 over x minus 9. What you'll notice, hopefully, is that you are dividing by a what here? Binomial, right? Not a monomial. So you cannot just do what we did in the previous two examples. You have to do something else. And the something else is called long division. So I'll write this down. Since denominator is not a monomial, we use long division. Long division. That's what it's called. And now that I think about it, I'm not quite sure why they call it long division. Maybe because it's the long way? I don't know. But it kind of gives it a negative kind of feel, doesn't it? Long. This is going to be long division. It's going to be something not fun. But it doesn't have to be like that. Just let's repeat the same thing we've been doing, all right? The 15 divided by 3, the 15 divided by 4, that same thing. So if this were the problem, 15 divided by 4, right? If it were, we have a numerator and denominator, and we did that division box, what would go into the division box, the numerator or denominator? The numerator needs to go into that division box. Now, very important here. We talked very little about what was called descending order. Do you remember us discussing descending order? When you have a polynomial listed out and you list it from highest power down, that's called descending order. When you do long division, the first thing you need to make sure is that your numerator and denominator are arranged in descending order before you start putting them into the boxes. If it needs to be. This one doesn't, because it's x squared, then it comes down by a power to x, and then no power. So that is in descending order. And the denominator is also descending. X and then no x's. So because it's in descending order, I will now create my division box. Now, that's correct. You only need to do this. When you're doing long division, you have to make sure it's descending. Okay. When you do this on your page, wherever you are on your page, like if this is your paper right now that you're writing on, you do your division box, you need a lot of room below this, okay? So if you're at the end of a page, you might want to start a new page, all right? I mean, you only need maybe half a page, right? Not like, just saying if you're right at the end, go to a new page. Okay, here's my division box. And I'm going to make it pretty big because what's going in there? 7x squared minus 59x minus 36. Okay, now just like in my 15 divided by 4, the 4 went on the outside of the box, so here what goes on the outside? X minus 9. Now, I'll do it next to this again. I have the 15 and I have the 4, right? So what we said to ourselves with this problem was, what do I multiply 4 by to get close to 15 without going over, right? That's difficult to do in this, right? It's like, what do I multiply this by to get this without going over? Well, I mean, come on, seriously? So there's a better way of attacking it. All you do is this. You look at the first term, which is x, right? And then you look just at the first term on the inside. Y'all know what I mean by first term, right? Okay. And you ask yourself, what do I multiply x by to get this? So I need a 7, don't I? And to make it an x become an x squared, I need an x, right? So I need to multiply the x by 7x. So if you want to, you could, that's one way of doing it, just visually doing it, all right? Or how many of you feel like that would be okay? All right. Here's another way, just in case you are not comfortable with that. What you could do is you could take the 7x squared and divide it by x. Okay? Take this and divide it by this. And that's a monomial down here, and then just cancel the x's, and that's just 7x, isn't it? That's what you would multiply by. So either way, we all come up with the same thing. 7x, agreed? I'm going to put it up here. 7x. Now back over here, we said 4 times what is 15? We said 3, right? So we put the 3 up there. Then what did we do? 3 times 4 was 12, and we put it here, right? So we put the 12 down there, and that's what we have to do here. We have to take the 7x times what? This whole thing, and put that under here. Okay, so that's my next step. Now what I'm going to do is I'll do it on the side, and that's where you should do it. I'm going to do this multiplication right here. I'm going to do 7x times this right here. So on the side, if I write that out, it's 7x times x minus 9. And this is just a little monomial times a little binomial. And you're just going to distribute it through, right? And what would you get? 7x squared minus 63x, right? I wrote that really small, but isn't that what you would get? So what we need to do is we need to put that answer underneath here, just like when we did 3 times 4, we put 12, right? So put your 7x squared minus 63 here, 63x here, and make sure you line things up. This is critical. I need to put the 7x squared I just got right underneath the x squared. We can look at this almost like an x squared column. Okay, you'll see it? Now, the negative 63x would go right under the negative 59x. Now, just like we did over here on the other one, we came in here and we said, oh, this is 12, and then what? This is so important. Then what do we put 12 here, and then we did what? Subtracted it, right? Which makes it a negative 12, doesn't it? Well, we have to do the same thing here. We have to multiply 7x times the x minus 9, bring it down, and then subtract this. When you subtract it, it changes the signs of both of them. So the 7x squared now becomes a what? Minus 7x squared, and the minus 63x becomes a plus. Now, how are you going to do that on your page? I don't know. You don't have colors. What I usually do is just like with the pencil, just like real dark over it, so I know that I just changed the sign. Do you see, though, the connection to... I'm sorry? Why did you change signs here? Right? That's what we did here. We did 3 times 4 is 12, and then we subtract this and come down. That's the same exact reason we do it over here. Do y'all see these two are almost the same? I mean, do y'all see the connection between these? Now, what did we do here? We said 15 minus 12 is 3, and we put the answer, didn't we? So this is 3. So what we need to do here is take this and come down with this. So what is 7x squared? Take away 7x squared. 0. So I'm not going to put anything. Is that all right? I'm just going to put a line through them both like they cancel. And when you do long division, that first guy should always cancel. If this first one doesn't cancel, you didn't do it right. Something's wrong. Now, what is negative 59x plus 63x? 4x. And then you have negative 36, and you want to put it together with what? Nothing, right? So it doesn't change. It's still negative 36. If you wanted to, you could imagine that there's like a plus 0 down there, if that helps. But it becomes a negative 36. So nothing changes. All right, y'all with me? Okay. Now, over here, what we did is we said, all right, does 4 go into 3? And we said no, didn't we? And we said that was our remainder. But we have to do something a little different here. We still look at that x out front. Okay, I did it with blue now. And now we're trying to say, does this x go into this? So we focus on that first term again. Can you turn x into 4x? How? multiply it by 4, right? If I take x and I multiply by 4, I get 4x. So I can turn x into 4x by multiplying by 4. So I put that 4 that I'm going to multiply where? Up on top, up here. So we're going to go through again and do it. So I put plus 4 on top. And now that plus 4 is going to come through and multiply times those two again. So we're repeating the process, yes. Not 4x, because I have the x already, right? Oh. So I need to turn x into 4x. I don't need an x, I just need the 4 to make a match. So I'm going to do that on the side over here. I'm doing 4 times the x minus 9. That's 4x minus 36, isn't it? And where does that go? Right here, underneath this, right? We good? No? This 4 times the x minus 9, right? Is that 4 times the x minus 9, which is 4x minus 36, right? But where do you put it? Yeah, it's going to come right under here, and then we're going to subtract it and see what happens. So that answer right there goes right underneath as 4, exactly what is 4x minus 36. And then I come through and change my signs. So this becomes a minus and this becomes a plus. So I'm going to do that like this. I'm coming here, I'm going to go minus 4x plus, I like to really exaggerate it, that I changed it. And then you add down. 4x, take away 4x. Gone, right? Negative 36, add 36. Gone. 0. We had no remainder. So this was like 15 divided by 3. Remember 15 divided by 3 is 5 and nothing left out over? Well, 7x squared minus 59x minus 36 divided by x minus 9 is 7x plus 4 with no remainder. That's a lot more difficult than monomial division, right? So what's the answer? I come back up here. What is the answer? The answer is 7x plus 4. Box it. So fun is what we're having right now, in case you weren't sure. Shall we do another? Yes, of course, right? I think you can appreciate why people don't like this. Negative 9 x cubed minus 11x plus 12x squared minus 500 all over x plus 3. You have division, right? Polynomial division here. The numerator has 4 terms, doesn't it? Unfortunately for us, the denominator has 2 terms. So it's not a monomial, it's a binomial. And because it's a binomial, we're forced to do long division, right? Okay. Now, here's my box. What do I put inside that box? The top. So it would be what? Negative 9x cubed. Good. Plus 12x squared. Who else caught that? It has to be in descending order. See the way the problem is written? They put negative 11x before the 12x squared to try and trick you, to try and get you to accidentally write it exactly the same way. But I'm changing the order to make it descending when it goes into the box. I'm going to do another example after this. You'll see there's another tricky thing that can happen. But we'll baby steps. You got to crawl before you walk, right? And then on the outside, the x plus 3. Everyone see that? So maybe make a little note up here to yourself. Switch these. Switch order. All ready? All right. What am I looking at? The x in front here and the what? Negative 9 x to the third, right? That's what I'm focusing my attention on right now. How can I turn an x into negative 9x cubed? Well, I need a negative 9, don't I? Okay, so I need negative 9. How do I turn x into x cubed? I need an x squared. Now, I'm going to take what and multiply it by what and put it where? Negative 9x squared, multiply it times x plus 3 in parentheses, right? And put that answer where? Underneath this, right? Now, last time I did it on the left, but it was a little hard for me to squeeze in there, so I'm doing it on the right. Negative 9x squared, and then x plus 3. By the way, you do not have to show this step. What I'm doing over here on the side, you do not have to show that. But if it helps you keep everything in order, then do it. So distribute that through. What do you get? 9x cubed, and then minus 27x squared. So that's what I get on that the first what we call iteration of the long division. Okay, our first pass through, trying to figure out what's going on here to turn our x into this. The first time through, we're going to have this underneath. So line everything up. Make sure you get your x cubed underneath your x cubed. And our next one is a negative 27x squared, right? So make sure we line it up with the x squareds. Then come through and subtract, which means change our signs. They're negative, aren't they? So they both become positive. All right. What happens to the negative 9x cubed and the 9x cubed? They cancel out. And that's what should happen, right? That first one. Now, the second one is not going to guarantee cancel. What's 12x squared plus 27x squared? 39x squared. Yeah, remember, we're adding these things together, so they have to be like terms, which they are. So all we do is add the numbers in front. So 39x squared. What else? Bring everything else down, right? Don't change the signs, though, right? Because there was nothing underneath the negative 11x and the negative 500, there's nothing under it. Just bring them straight down. Okay, we focus our attention again. This time, I'm going to look at the x, and I'm going to look at 39x squared. Yes. Uh-huh. That's what I was saying. We're taking 12x squared, and we're adding 27x squared. This is addition of two like terms, right? So this is back to the beginning of this section. We keep the powers the same. We add the coefficients. Okay. Oh, no. We all need to be clear on it. That's what we're here for. Okay. Y'all agree I'm looking at 39x squared? Okay. What do I multiply x by to get 39x squared? 39x. So I go up here and I put that up here, plus 39x. And I'll do that work over here on the side. I'm going to take my 39x and I'm going to multiply it through the x plus 3 again. Y'all okay with what I'm doing over here on the side? Okay. This is 39x squared and then plus, what's that? 120, 117, yeah, 117x. So this is just like little scratch work I'm doing on the side, just to keep everything in order. I put that answer where? Underneath that, right? 39, line things up, 39x squared, wow, plus 117x, and I don't have anything else there. What now? Switch the signs, switch the signs. Now this becomes a little bit weird because I make this negative 39x, and I have a plus here, right? It's hard to change a plus to a minus. So you either have to really exaggerate the hell out of it, or you have to be using a pencil and erase. I mean, it just depends. I just exaggerate the hell out of it like this. I just make it like this super subtraction symbol that covers up my plus. So I know that I changed it. The 39x squareds cancel, right? What is negative 11x take away 117x? Negative 128x. Then what? Bring down minus 500. Ay, ay, ay. We done? Nope. Because can you turn x into negative 128x? Yep. All you have to do is multiply by what? Negative 128. And then you do that on the side. It was negative 128 multiply x plus 3. It's negative 128x minus, let's see, that would be 390, 380, 384x. Or, yeah, no, just 384. Right, because we didn't have an x out here on the negative 128. Again, do y'all follow the procedure here? This back and forth through this thing? All right, put it underneath. Negative 128x minus 384. And then I get to come through here and I get to change the signs, right? So if I change the signs, it becomes plus here. That one becomes plus. The 128x's cancel, and I have negative 116. Well, yes, but we need to understand why we stop, okay? Why do we stop at this point? Not because it's a number, because can you turn x into negative 116? No. And there's ways, but not we won't talk about it here. Right? There's no more x's here, right? So we pretty much can never make that x turn into something without an x. Make sense? So we're done. But that's our remainder. Okay? So now what we need to do is we need to put up here to the side r negative 116. But that's still not the final answer. Because remember when I did the 15 divided by 4, I said back in the old days we would say remainder 3, but what it really meant was this. We need to figure out what that really means. So I'm going to bring all this down for my final answer. You're going to help me out. Final answer is the negative 9x squared, right, plus 39x minus 128 plus. Now, you always use a plus sign here. I'll even make it blue. Always use a plus sign. Now, what is the remainder? Negative 116. You put the remainder, negative 116, divided by or over the divisor. What was it that we were dividing by? X minus 9. Or wait, x plus 3. Now, if your remainder is 0, you don't have this, do you? Like in the previous problem, we didn't have this, so we were done. But if you do get a remainder, you have to always put that remainder over the divisor, and now you're finished. Damn. It's exciting stuff. What's that? It needs to look like this, yeah. I mean, you'll get partial credit, but not full credit. I mean, I could almost give you, a couple of these, and I knock out a couple of different skills in one problem, don't I? I mean, there's a lot going on in here. How about, I know you're exhausted because of this. Hold on for a second. Last example. I didn't realize this would take this much time, but that's okay. All right, we have division, right? We have, unfortunately, we don't have a monomial on the bottom. Now you see why having a monomial on the bottom is nice? Okay. We actually have a trinomial. But that doesn't matter. If it's not a monomial, we're going to long division. So we need to set up our long division box over here. And watch this, all right? Don't write anything down yet. Check this out. This is critical. It needs to be in descending order, doesn't it? But what I want you to notice is that you have an x cubed, but you don't have an x squared, do you? But when you do your long division, you might actually get some x squareds. So you have to account for it by giving it space in the box. So what we'll do is we'll do it this way. We'll write 0x squared. We don't have an x squared, do we? Up on top? But I will make a spot for it. You'll see, it'll come together here, all right? Next, do I have any x terms in the numerator? No, but I need to account for it in the division box to give myself room down here to line things up. You understand what I'm doing? Now, after x, I have numbers. So do I have a number? Yes, plus 1. Now, the divisor, x squared minus x plus 1, I put that in descending order outside. Are you ready? Okay. I'm going to look at what? X squared and x cubed, and ask myself, how do I turn x squared into x cubed? I just need an x, right? Multiply it by x. So I'll just put x here. And now don't you have to take that x and take it and multiply it times that whole thing here, just like we did before? So again, I'll do it on the side. I'm going to do that x that I'm going to multiply, and it's going to go times everything. Will you mind shutting that door on your way out? I'll get you this stuff back next time, okay? All right. Some people really don't like long division, as you can see. They just leave. No, he told me he was leaving. Okay, so that's that. You understand what I did over here? I'm going to do that x times out here. So that's my x times the divisor. And then I distribute the x through. I get x cubed minus x squared plus x. I'm supposed to put that underneath, right? Now, let me show you something. I want to show you. If you had done it this way, and then you came in here and you still said, okay, oops. And you said, okay, x cubed, x, I need to multiply by an x here. And then you would have done your x times that over here. You get your x cubed minus x squared plus x, right? And we need to put that underneath. You see that we're not going to have places for things? Our x cubed will go under here. But then where do we put the minus x squared? See what I'm saying? Like there's no, where do I line it up? And so it becomes a big cluster, you know what, right? You've heard that before. And we don't want that. So that's why in the beginning we accounted for everything with spaces. So when we line things up now, x cubed goes here, minus x squared goes right next to it, plus x goes right next to that. And then we come through and we don't forget to switch signs. So minus, this becomes a plus, this plus becomes a monster minus. And then you bring it down. Let's see what we get when we bring this down. 0x squared is like there's nothing there, right? So I'm saying plus x squared. So that's just x squared, isn't it? Like just it's like a 1x squared. So I just get x squared here. And then the next one, I have nothing. I have nothing. 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 I won't sing. I don't want to blow my voice up today. Minus x. Is that okay? Plus 1.
So we can cancel the 0x cubed with x cubed?
Cancel. You can't do anything with it. I mean, just imagine that that's not even there. They're not even, because they're like zeros. We're only keeping them there to give us spaces to put things in a column. Are we done? No. So now we look at the x squared out front, and we look at the x squared again. X squared, how do we turn x squared to x squared? Can we turn x squared to x squared? Multiply it by what? 1. Right? I multiply by 1? Okay. So let's do it. Put a plus 1 up here. And then, you know, do your little 1 times the x squared minus x plus 1 out there. And 1 times anything is itself. Same cycle here, right? Place it underneath. Change the signs of everything. Add down, and you should get what? 0 all the way across. So we should get 0, negative x and positive x is 0, and 1 and negative 1 is 0. So we get 0, which means we have a remainder of 0, which means our answer is what's up there by itself, x plus 1. Ooh, my stomach's growling. X plus 1. Okay, I think that's sufficient. I was going to hand these back, but I think I'll keep them. Just for the day. I'll have them for you on Thursday because I want you to be able to take these home and use them to study or whatever. So I will get those back to you before the exam. I'll take attendance based on these, all right? Let me give you your homework assignment. All right. Now, I had made this homework assignment before class, so it seems long now that I'm looking at it. Let's see, page 384. Let me trim it a little bit. That way you'll at least feel like it's doable, because those take some time, all right? Number 9. Number 17. I'm going to list these kind of in order. Those two are monomial division. That's what we started the class with. And then 21, 25, 41, I'm trying to find one that has some gaps in it. You know, back it up. 37, you do 37. And then 51. That's it. I mean, those are all long division problems. So I anticipate you'll come to class with questions possibly on those. But remember, the answers are in the back of the book. All right, so try and get to that answer. Everyone have a great day. I need to sign your thing? Okay. And I will stop my recording real quick.